I will announce the next speaker. So enjoy and have fun.
Great.
Yes,
Thank you. Thank you, Marvin. I hope I'm audible loud and clear for everybody. Uh, am I audible loud and clear?
yes. You are live.
Great. Thank you. And so, good morning, good afternoon, good evening for you guys. I know that there are a lot of people joining to this overall session across the globe. So, welcome to my session, and hope you had a very enjoyable and knowledgeful sessions. The previous parts. So in this hour, we'll be discussing about exploiting and defending CI/CD generally. So the moment when we see the word CI/CD or the word DevSecOps, a lot of people would think this is something like a defensive part. I do agree that there are a lot of teams, a lot of companies, even a lot of security professionals think uh, we have two dimensions or two verticals of security. We have offensive security and we have defensive security, where offensive way we proactively identify bugs and start fixing it, or like typically we would mine vulnerabilities. It's similar to mining of vulnerabilities. And defensive part is where we start fixing the vulnerabilities or build up a wall so that nobody could cross the border and exploit our systems, right? So a lot of person have, or until now, a lot of, we used to think that CI/CD would be, or DevSecOps generally would be, it's only in terms of defensive part. So until now, until a couple of years, nobody have thought or had thought about doing connectivity activity or pen testing CI/CD environment, because we were thinking how to align with how a security can be aligned with SDLC and go forward. So this session would be a bit of off track into that perception. So here we are going to be in a simple way, we are going to be pen testing CI/CD. So this overall session is all about, so how do you pen test CI/CD environment? And yeah, let's start and let's dive in. So, a quick intro about myself. So, my name is Bharat Kumar N, with a tagline of BKOB. I usually refer it as 8K0B. I started my career as a pen tester. So, and then I did a wide variety of pen testing. It could be network, web application, mobile, cloud, and IoT. So currently, I also work as DevSecOps. So now I'm much into DevSecOps and cloud security. You could frame a word like a jack of all trades. Obviously, yes, it can be mastered by of any domain. So that's the background of me. So let's go forward. So as I said, today we are going to revolve a lot about SDLC. So let us just have a small brief about SDLC for the people who are new to this environment. Obviously, we have diversified security audience. So let me just push a bit about what is SDLC. So SDLC generally means software development lifecycle, where it's a process, or it defines about how does a software is developed right from day one to the end, right? So it just continues like what all is usually done by in the overall SDLC part. So what are the process that we have when a software is being built? So usually what happens is whenever a software company wants or even thinks of building a software, so they first have the requirement. It could be a sales team, could be somebody's idea, and this idea would be drawn into a design, usually by a technical team or an architect. Then that particular architecture is being codified, or they write code, they develop it. And once the codes are developed, obviously we have to check if the code is working properly or not. So we would be doing testing, and once the system is tested, if it works perfectly fine, then we go for deployment. And finally, once the code or website or app is being deployed, then it goes to the maintenance phase, where we start maintaining it. Now, this is a generic way, or traditionally, this model which I'm showing you here is also called as waterfall model. Sorry, yeah, waterfall. Sorry for that. a waterfall model. So typically, this is like a very old or traditional way of SDLC. We do have agile and a couple of other ways, but the moral part here is, if you see the earlier time of SDLC, we used to the overall development stage by stage. Let's say if you want to build a website, the entire website is been designed once, and the entire website is been developed once, and then the entire website is tested, and entire website is deployed, and entire website is maintained. So this will take a lot of time. Firstly, because you're building an entire website. Again, depending upon the features and the size of a website, the duration would be prolonged to a couple of months, or couple of months to probably sometimes even a year also, if you are using a very big websites. So and let's say if one stage is halted, the overall process is halted. Say for example, let's say while testing, if something got broke, right? So again it goes back to the developer, and there it takes more time, it gets consumed, and thereby it increases the overall development phase. So the main problem with traditional SDLC that we had, it was very time consuming and very resource consuming. Sometimes that was a major drawback. Again, there are a lot of drawbacks, so I don't go deeper into it. Just give you a brief. So this was a major concern, because of which we came to the context of pipelines. Now, obviously, you don't have much text, so a standard disclaimers that you will not have much text in my sessions. You'll hear lot of images in the overall PPT. So we started moving from the holistic development to development from sprint wise or stage wise. So instead of building an entire website from scratch to end in a single shot, so later people started thinking, let us build it by stages or chunks. So we build, let's say for example, we build the let's say take an example of YouTube, because a lot of the audience are seeing this thing from YouTube. So let's build a player first, and once the player is built, in the second release or in the second version or second update, let us build a subscribe button, or in third let us build comment, and so on. Let us build playlist, let us build join buttons or community. So this way each so we would first build a skeleton and start adding multiple features in each releases. That is why this overall thing was in a release cycle ways. So that is why even today we see a lot of companies or a lot of applications, we get updates at least 1 week once, because they don't build the entire application in a single shot. So they build things based on features. Now you might be wondering why do I have a car assembly line here? Okay, so because this is a very similar thing what we do in today's SDLC. So instead of building all a chunk, one all entire website in a one stage, if you see the car manufacturing, a car is not manufactured right from top to like from scratch to end in a single slot, right? So different parts are manufactured by different places or different departments, and finally all the parts are assembled to take away to one particular car. Now, if you see an average car manufacturing duration, a typical case, let's say if you take a mid variant of the car, a car takes around 4 hours to get manufactured. So within 4 hours, you get one car manufactured. Now, how is this possible? Because instead of building a car right from scratch to top and in a single stretch, we started building the parts, the different elements of it parallelly, and you bring everything into one sections, right? So people start doing their job, and the other guy will bring those components into one position, and they start assembling it. The same thing what we called in the later version or the agile methodology or the latest SDLC mechanism called as DevOps. Okay, so earlier what used to happen, the developers used to write code, then they used to give it to QA or do the testing, and once the testing is done, then used to give it to the operational people, where they start deploying it, right? So instead of having these stages one by one, and thereby if say, let's say for example, if the test fails, the duration of the development would go much more bigger. Similarly, if the operation guy has any issues, or if something fails, during the operation, again that will also prolong your overall build, right? So we had these problems. So let's say that's the reason why people start using things called as DevOps. They merged both the development and the operations. So now what happens, instead of developer just writes the code and sends it to ops and just sit back and relax, instead of doing that, we have a very similar thing called pipeline here. Just like we have assembly line or a pipeline for a car manufacturing or any kind of a manufacturing in today's world of industries, we have pipelines even on our SDLC as well. So what do we do there? It's pretty simple. We put up a streamlined process where we automate certain things, right? So we have a common in IT. We have a common saying that anything that you do repetitively, it's better to, or it is efficient to codify it or automate it, right? Same thing that people have done here with the context of DevOps. So the overall process is being streamlined into an automation process, right? So now what we do, we our developers, they write a code. Obviously first they plan it, they write a code, and the code, instead of storing it on their personal computer or one centralized server, so they store it into a one particular code repository. Okay, so it's a big server where we can, not physically big, so it's capacitively, it's a pretty big server and easy to handle server where developers, even multiple developers, can collaborate their code and push it into one particular location or one particular server, and so that instead of the operation or the next stages, instead of taking the code from the developer's machine, they would take the code from one particular folder or a server, which in today's world we call it as version control systems. Okay, or in some cases we also call it as SAM or source code management tools. Okay, so we the developers write the code, and the on the working code they push it into the SEM or VCS, and that code then goes for build, right? So they will, the next team would compile it, and if they have any issues or errors, that will be identified. And if they have any errors either while compiling or while building or any other errors, the SEM or the next stage tool will alert the developer, stating that your code has a bug, and obviously the developer would again go back, write the code and fix it. Now this part is very efficient because if you see the overall, the earlier case, if you see the waterfall model, there the developer would write a code, send it to the next team, and he's busy with some other code, right? By the time when the bug comes in the waterfall or the traditional SDLC model, the as a human tendency, in most of the cases, the developer would have forgotten. I mean, at least not 100%ly, but certain elements the developer would have forgotten it, what he has written or how is it written. So obviously, it will take some time for him to understand his own code, because he would. I mean, frankly speaking, in real world, the developer will not just write one code, right? So his job is to write multiple codes, right? So the amount of the considerable amount of time is invested by the developer when he gets the code that he himself has written after a couple of months. So in this case, with the help of DevOps or source code management tools, the moment when he pushes the code to the build, to the CI/CD pipeline, there itself he gets an alert that this code has a bug. So he could, so since he's just written it a couple of minutes or hours before, he would have those code in fresh mind, and obviously he can fix it far better, and thereby reducing the overall time of development. Okay, now once the developer writes the code, he finishes the code, everything is working fine, then it goes to the build, where a certain version of the code is being clearly written, and then it goes to the testing team, where they test for the quality, they test for the performance, they test for the load, they do a multiple regressive amount of test. Now olden days, this test was done manually. Now with the help of CI/CD or with the help of DevOps, this thing is been automated. So just if the if the developer writes the code and save it into the SCM, the code would be automatically pushed to the build. It would generate a build. Then the testers would start writing his own test cases. He would have already written the test cases to the CI platform or the server on which this entire operations are happening, and thereby it would recursively go to the testing, performance, load, what is and what not. It will go to testing. In case if the test fails, then obviously the loop will go back to the developer, and again he would fix it. Again that would be builded, and again it would be tested. So this is a recursive process. Each stage, when something fails on a stage, it has been alerted to the developer, and the feedback is given to the developer, obviously, to verify and if everything is going good or not. Okay. And in this stage, the development, build, and test, when all the three tests are passed, then we go to the release cycle, where the operation guy, what he used to do earlier is he used to create a server by himself. He used to provide the configuration, he used to work on the networking, he used to work on the patching, he used to work on the cycles. A hell lot of job for him, right? Now, the entire job of patching, network installation, network configuration, system installations, and the configuration management, entire thing has been automated. And the same thing can also be scheduled as well, of what has to be picked, and when it has to be picked, and what else has to be added. Those things is been automated, and the same thing can also be deployed as well. Now it can also, because of the advancement of cloud and these automation, we could also have the blue green deployment strategy or a couple of other strategies as well, and you could start deploying it without even manual intervention. Now obviously here also, if something goes wrong in the release stage, obviously this will be informed to the DevOps or the SRE, or whoever the person who is working on the configuration part of it. And at the same time, when it is being deployed, again it is being informed to the SRE or the DevOps, so where something has gone wrong and some of his code has been broken, and that would be passed as a feedback to him, and so that he can go forward, make his changes on his code, and so that the cycle goes on again. So until now, the code has been deployed, a website is ready, and or the app is ready. Now, even the operation and the monitor part also can be automated in such a case that you would have a dedicated servers or components which are recursively monitoring your systems. And if there is any alerts, or if there's any changes, if there's any um, uh, or attention that's been needed, that need to be given, then it would create an alert, thereby it is being sent to the concerned team. So typically what happens here is the overall process, we used to have manually, inclusive of, like, let's say 5 to 6 people. That entire thing has been automated with less amount of manual intervention, and at the same time with a streamlined process. So whatever process used to take around 6 to 8 months earlier, the same process can happen within 3 to 4 months now, or even less, depending upon how mature your model is. Okay. Now this is why it is also called as CICD. The reason is because the developer, because it's been streamlined process now, they don't need to worry more on the sharing the packages, sharing the files, troubleshooting it, recursively testing it. They don't need to worry much on the later process. They only need to worry on the development. They only need to concentrate on the development. So because of that, he has more productive amount of time, so he can start building new features, and he can start pushing it onto the SCM. So as soon as a developer writes a code, automatically it goes to the build, it goes to the test, it goes to the release, and gets deployed. Now the developer is continuously integrating new features, and at the same time, at the end of deployment, you get a new deployment, or you get a new release of a file. Let's say if it was for a exe or APK file, you get a new file delivered, or if you want to create, if you're creating a website, there is a new website is being deployed. Okay, so the overall aspect here with the DevOps is entire process is streamlined with a less manual intervention, and we have a more automation here, thereby increasing the productivity and thereby decreasing the overall durations. Now, this is the greatest advantage of DevOps. Okay, and so I hope so far it's making sense and it's clear. Is there any questions in the Twitch or the YouTube? Anybody, Melvin? Any queries, concerns so far? Is it going good? I hope it's going good. Any queries, concerns, or any issues from anybody? Am I audible, Melvin? Uh, okay, let me just cross verify if everything is working fine. Okay, you don't see any replies. Am I audible? Clear? Is it visible? Audible? Can anybody give me any response? At least in the Telegram channel as well. People who are viewing it.
Can hear you.
Yeah. Great, great. Thank you for that. So I hope I've given you a good brief about what is DevOps and how does it work with the real world. Now, obviously, you would have been thinking that we were thinking about we would have something on pen testing. Why are we talking about DevOps? So, to understand pen testing, ideology of the overall pen testing is to understand a context and start testing it. So that's why I just want to give you some brief about it. Now, typically, this is how it works. Each layer people would add, and you would get a feedback on it. So that's the theory, and practically these are the tools that we typically use. So CI/CD or the DevOps is nothing but these are elements. We write a code, we build it, we test it, we release it, and we deploy it. And once it is deployed, we start operating and monitoring it. And to do all these parts, we take the help of a different tool to write a code. We write a code and push. We use Git to build. We use Maven, SPT for testing. We may use JUnit, Selenium, depending upon your programming languages. And to get your all automation done, we use Jenkins, GitHub Actions, GitLab CI, Circle CI, Travis CI, all this XYZ stuff. For deploying, we would be using AWS, Docker, Kubernetes, what else and whatnot. And for operation part, we use Ansible. Sorry, for operation we use Kubernetes, Ansible, Chef, multiple parts. And for monitor, we will be using Splunk or Datadog, or it could be any SOC or SIM tools. So these are a collection of various tools that we use for this overall process of CI/CD to work properly. Now, until now, if you are a developer, you would be overwhelmed and you would be very happy about because you have less amount of problems in your mind, and you are very productive, and your manager is happy, your customer is happy, your sales team is happy, and you live in cloud nine because everything is going good, and you are like literally you have everything running perfectly fine, and yeah, you're good. Okay, so that's how typically a developer is, and that's not the real world, right? So if everything is going good, most of the times uh, you're doing something mistake. Okay, so that's what happens in real world. So if everything goes good, if everything is silent, it some way means it's not going good. So that's the reason why I was picking you guys. Yeah. So coming to this part, if you see this, these are all the overall advantages, and we have these many tools here. But if you observe, out of all these parts, so you should have some a mastermind, isn't it? So even if you have these many amount of tools, there should be one tool or one couple of collection of tool, which is very common or which is very needed or very powerful. right? So that tool that I will say for CI/CD, or the most critical tool or critical part for any CI/CD would be your CI tool, or continuous integration tool, which we call as Jenkins, GitHub Actions, GitLab, or GitLab pipelines, or Azure pipelines, what is and whatnot. So these, now, why do these tools are very important? Because if you see, the ultimate background or the backbone of your overall CI/CD is the automation. And if this automation has to happen, it has to happen on some computer, is it not? Previously, it used to happen on the developer's computer, or the DevOps computer, or the operation guy's computer. But now, since it is being automated, it has to happen on some computer, is it not? Now, where does it happen? It happens on the Jenkins machine. So when the code is tested, it is tested on the Jenkins machine, or basically the CI tool. When the deployment is happening, before the deployment is happening, the image is created on the Jenkins machine or the CI machine. So all your automation happens on one machine called as CI machine, or your continuous integration tool, or we call it as engine. Again, we can give a different names for it, but ultimately all your automation happens on one main critical mission. So your code is there, your credentials are there, your artifacts are there, your network configurations are there. So this is like God, okay, the demigod. So that's why I say it's the most powerful uh, element in your overall CD. Okay, so his power is beyond anybody's comprehensions, right? So that's how powerful a CI tool, because he is like a god for overall deployment, because he has the code, he has the credentials, he has the passwords, he has the network, he has the artifacts, everything he has in home. So obviously, since he has everything, he has a lot of power. And obviously, people say that when you have great powers, with greater power comes greater responsibility. So when you have more power, obviously you have to use the power with greater responsibility, or else you lead up with a lot of other parts. Now in security, the mistakes made by one person, obviously it will yield with multiple people. Obviously, a lot of people will have to serve their like serve their dedications, make their dedications go in vain. So these, so far we're talking about the advantages of SDLCs and DevOps, all this part. Now, this are a few eye openers for you to give you about what can go wrong with these automations. So usually in security, we have something called security triangle, where the security features and the usability has to be managed. And the moment you start increasing your features and usability, the security will go down. So that's the common tug of war that we usually play, where we try to manage everything. And if one of the thing is not balanced, the other one would go up. So if the security is not balanced, or if the features are too high, you're making everything easy for the people, and obviously there would be some point where the security would be compromised. So these are the few famous examples where security was compromised, or more precisely, a company was compromised, the entire organization was compromised through some mistakes. Now, again, there are a lot of incidents that have happened. Let's say. So I have given you a couple of famous incidents. Now I'll not go deeper for everybody. I'll just give you a background of what happened. So, for example, with SolarWinds was a platform where a lot of people were using it as a supply chain, where a lot of people were using their components to support with other their work line. So there are a group of hackers who hacked SolarWinds, and because they hacked and put malware into SolarWinds, they had compromised all the clients. So this is a tagline that we say: instead of compromising 100 companies, what we can do is we can identify from whom does these companies take the softwares, and if you just hack one of that mastermind, and everybody who follows them will be a slaves. So that's what happened. So when SolarWinds was hacked, or the malware was added into SolarWinds repository, so which of the clients who were using SolarWinds, they automatically get compromised, and their data was breached. And same thing happened with also with PHP. So somebody put a one-liner malware onto PHP. So whoever has updated the latest version of PHP, they all got infected with that. So similarly, the Stack Overflow breach was happened, and so it was a massive breach, and a lot of until a couple of time duration, the company itself didn't know that they had been hacked. And later, again, a couple of other secret issues that got leaked. So usually we store credentials in our CI, and that's a critical element, which we are going to be discussing that in a couple of minutes. That again, these two factors like CodeCov and Travis, where the secrets were exposed, and thereby disclosing a lot of critical data of their users. Lastly, the very recent hack that I would like to shed light on it is 3CXX hack. This was actually on the virtual PBX network, where a lot of people who were using, I mean, we could also categorize this as a supply chain attack, but in terms of SDLC, supply chain attack is a part of SDLC attack. So, so people who were using 3CX also got hacked. Again, the same principle would apply here. That instead of hacking 100 companies, you hack the one company where all these guys use the components, and you in return others would be your slaves. Just similar to that. Okay, so again, this is something like until from past 25 minutes, I was just maximizing, or I was just putting everybody. I was just celebrating the developers and DevOps, and all of a sudden I brought them down. Okay, so this is something that you would have been thinking that way, but so you might be also thinking that no, this is about DevOps. So in industries, there's something called DevSecOps. Obviously, when you start implementing DevSecOps, these things should have come down, isn't it? So I do agree. Where we say we have a word called shift left, right? So if shifting right doesn't work, let's ask them to shift left, right? So that's where people or companies started adding up things onto left. Now they started implementing security in the earlier life, or right from the design stage, right from the coding stage and testing stage. They parallelly added security in this. Now, I'm not saying this is bad. This is a really good job, and it is being proven in a lot of companies. They are really doing great here. But in security, one implementation, or I would say one rule, does not apply everywhere, right? So it's not like we have a defensive of depth, right? So each layer, or adding defense in each layer, is more important, rather than they're just like, I have purchased a firewall and I'm secure. So that doesn't work in security, is it not? So shift left is exist, but shift left has its own advantages, and obviously it has its own limitations as well. So if we just say, just by shifting left, is my SDLC is safe and my company is safe, and that means you're just closing your eyes and walking onto highway, right? So no, you don't know which vehicle is going to hit you, right? So yeah, shift left is one element of securing your SDLC, but it's not the holy grail for you, right? So that's part. So what is shift left? So just give me an insight. So shift left is nothing but you're combining your security tools along with DevOps. So just like if you go back, just like you're adding a unit test, just like you're adding a deployment tool, just like you're adding a monitor tool, you're also just adding a security tool there. So typically speaking, you're just adding SAST scans and DAST scans into your CI tool. That's it, nothing else. So typically what you're doing here, you're just performing a scan. So whatever we used to perform scans earlier, we're just doing the scans here. So obviously, yes, it does give you a lot of advantages. So frankly speaking, the amount of money that a company used to spend, or the loss that a company used to face, identifying a vulnerability after production, would be drastically low. One of my previous talks is to explain that, let's say if you find a vulnerability after production, let's say if it cost you around $100, to fix it after production, the same vulnerability, if you would have identified in the coding stage itself, it would have only cost you hardly $8 to $10, right? So the same bug or same vulnerability, if you're fixing it during development phase, it would cost you $8 to $10. But if you're trying to fix the same bug after the production, it would cost you $100. So that's the breadth. That's a wide. That's how wide these security is all about. So obviously, yes, DevSecOps helps you there to get your vulnerabilities fixed in the early stages, but that is not the holy grail, right? Just by keeping your DevSecOps pipeline up to date, and if you are implement this fine, and if you are streamlined this process, it doesn't mean your CI or your SDLC is secure. Okay, so I hope you got these myths of DevOps and DevSecOps of being secure enough. I hope that is wiped out of your head. So now let us have some more clarity, right? So there's one common way, if you want to check anything if it is strong or not. So best way is to break it, at least try to break it. So that's what we do, right? So if you want to check if your bulletproof jacket is really bulletproof, obviously you start shooting it, right? If you want to check your if the glass is unbreakable or breakable, obviously you take a hammer and you break it. So if you really want to check if your pipelines are secure or our pipelines are strong, obviously we have to start hacking or breaking it, right? So this hacking or breaking in IT, we call it as pen testing, right? So I hope there are a lot of pen testers here. So again, just give me a sec. Again, we are just trying to pen test or kind of analyze what is the ground that we are running or how your SDLC is processed. That's what we are trying to do here. So pen testing is again we have been doing pen testing in wide variety of areas. We have doing it from web, network, IoT, mobile, a lot of things. So my point of this talk is also that we also need to do pen testing even on our SDLC environment, that is your CI, VCS or SEM or your deployment parts. So that is also so why are we putting these onto the corners? So that those things are also a critical infrastructure for us to work on. So obviously, yes, it is needed to be pen tested. If that's the case, so if you want to check how strong they are, you have to break it. Start breaking it. But where do you break it? You should know what are the loopholes, right? So you should know where you're looking for. So again, this is not an extensive list, or this is not the complete list. I would say these are the few lists that I have been following, or I have been using it, or I've been researching on it. But again, it's not an extensive list. This can go long, and depending upon different way of working, this can be different as well, right? So if you see the starting point of our overall SDLC would be our version control system or push code management, like something like a GitHub or a Bitbucket or Azure Code or what doesn't work on, right? So that has to be validated first. That has to be checked. You need to check loopholes for that. Let's say most of the time, a lot of startups keep their source code repository as a public. So that is a most big mistakes, right? So make sure it is private. Again, this is just one example, but you can have a lot of things. Let's say they are hard-coded credentials. People have done hard-coded credentials, or they are disclosing their private keys. They are disclosing some IP addresses, or let's say if since the code is public, obviously people can scan through it, can identify vulnerabilities through it. So that's one of the cases. So starting point would always be your version control system, something like Git, Bitbucket, and so on. And second thing, the most powerful factor of your CI/CD pipeline is your CI engine itself. So like your Jenkins, GitHub Actions, and so on. So this has a lot of powers in it. So, for example, let's say this life cycle of your CI engine starts with downloading the code, and obviously when it downloads the code, it would have the code physically stored on it, right? So that's the first threat that we have. Let's say if the CI engine is compromised, your code is compromised. Let's say if you have kept your VCS highly secured, but still if the CI engine is compromised, the code is gone, right? So that's first thing. Secondly, The CI engine has credential for each and everything, right? It does also have credentials to your VCS, right? Because of that only it is able to download the code. Now, if that token is not limited properly, or if it is not configured properly, then obviously, just like it can, if it can download the code, it can also upload the code. So if a hacker has access to your CI engine with the same token that the same token that is present in the CI engine, he can also modify the code. Is it not? He can also push the code to the master branch, right? That's one of the threat that we have. And secondly, since all the credentials stored are there, like even for deployment, we store the credentials there, and our Docker images or container images are built on the CI engine. That can also be manipulated. And let's say if you're doing a deployment, let's say if you are creating a Terraform plan or Terraform apply there, so this command or this instructions are running from CI engine. So if your CI engine is compromised, not only you can manipulate your target architecture or deployment architecture, you could also misuse it or misinterpret it. You can, let's say let's say for example, if I compromise a CI engine, and if I have your Terraform commands or Terraform credentials on AWS credentials, I can start doing Bitcoin mining. So who is stopping me that, right? So that's a level of threats that we have with CI engine. Okay. Now, obviously, yes, a lot of people might be saying that we have our VCS or CI engine in our private cloud, or we are doing it on premises. But trust me, the same was done by other companies as well. So the Stack Overflow also was running CI engine in their private cloud. They were also doing it with on premises, but didn't they got hacked? They got hacked, right? So again, I'm not telling you that you should not be doing one particular step, but I'm telling you that just by doing one step, your job is not done there. So let us have multiple layers of defenses. Okay. So lastly is the deployment environment. Obviously, yes, your deployment environment plays a major factor role, because your networks are created there, your your overall your actual servers are there, your data are there. So if that is compromised, obviously yes, your website is compromised, right? And it would also have credential of other elements. It would have details about CI, it would have details about VCS. So if your deployment is compromised, again, they can also go backwards and get the details. Okay, so these are the couple of areas where we need to look forward. Okay, so I know that there's a lot of theory, there's a lot of bombarded text and all those things. So let us go forward and let us get our hand dirty. Okay, so let me just show you about like a, let's say, just two hacks. Okay, yep, let us see around two hacks. And out of all the things that I showed you, I'll just take a help of a major kind of a practice mission for CI/CD hacking. This is called a cybersecurity CI/CD goat. Okay, so again, as of now, the most famous CI/CD platform to practice is CI/CD Goat. So apart from that, we don't have much tools available. At least the famous one that is available. It's a really good work from their contributors part. So even I'm using this. I'll not be going deeper about it. So I recommend you guys to work around with it, practice, and make your hands dirty. So I'll just take two, three scenarios from it. Precisely two scenarios on it, and I'll also try to do the same thing on GitHub Actions. I'll just show you about how it has been done, because again, the authentication, all this part will take some round of time. Okay, so in this current case, they have a couple of dependencies here. I hope that, obviously, you would be raising that point the moment I start hacking it. So as of now, in this current case, we do have access to Jenkins, the CA platform already. Okay, we do have credentials. We do have access here officially. Okay, so we can log in and check each of their activities. Okay, and that's the one of the things that we don't get in real world. So in real world, we don't have access to Jenkins, right? But I guess obviously there are multiple ways to get in. Let's say if you find a remote code execution vulnerability, or if you're able to crack the credential of one of the user, even though if it's a least privileged user, you can still do that. And secondly, we do have access to the GitHub or the Git of this particular repository. So I'm just gonna pick that. So there are two dependencies that we have here. So first dependency here that we have access to Jenkins, we have access to GitHub. So that two that we have, but again these two are not the admin level privileges that we have. We have only the guest user privilege. So again, even from a Jenkins perspective, we are only a read only user. We cannot edit anything. We can only see. Same time, for even for Alice, we are just a normal developers. We are not a master developer. We cannot commit directly anything onto the master branch. Okay, but let us see how these things can be handled directly. So I'll just give you, let's say I'll give you three different scenarios. Again, these three would be the initial challenges of CI/CD code. So I'm also planning to write a detailed walkthrough for all the challenges. There are like 10 challenges, if I'm not wrong, with CI/CD code. But yeah, so you can just follow up that with my LinkedIn and blog for that. Okay, so without wasting much time, let us make our hand dirty. So I've just logged into my kit here. So let me just show you what we're going to be doing. So I'll be picking up three vulnerabilities of our CI/CD. So let me make a mark. Okay, so ouch, sorry. Okay, so first I'll be making is pipeline poisoning. Sorry if I'm giving you wrong uh, spellings. Sorry for that. So yeah, it's not correcting. Yeah, great. Thank you. So yeah, first we'll be doing a pipeline processing. That is hijacking the pipeline, or we can also say like obviously exploiting the pipeline for yourself. Simple. And second thing is dumping secrets. Okay, now this could be anything. It could be the credentials stored in your CI platform. Okay, it could be credentials, it could be private IPs or public IPs, it could be your private keys that is stored in your CI. Now obviously this is dedicatedly we are hacking the CI. So here we are hacking the SCM, source code management, or VCS here because of misconfigurations, and here we are hacking the CI. Okay, we are hacking the CI. And lastly, let us dump credentials. Again, this is again secrets, but this we are dumping it from our GitHub, or basically SCM. So typically we are dumping it from the SCM. Okay, or VCS. So let us see how these things are done. Again, these are all the first three challenges of CI/CD GOAT. Again, if you want to have a detailed walkthrough, I'll be posting it in a couple of days. So these Christmas days are a bit of hectic from the work wise. So just give me some time. I'll be giving you a detailed walkthrough or a blog in my blog about all the 10 challenges. I think you can also find the solutions here also, but again, it's the solutions obviously. So let us try that. So we'll be doing these three parts. We'll be writing a pipeline. We'll be doing a pipeline personing. I will be dumping credentials two ways. One, directly from the CI tool. It can contain every secrets, private keys, private IPs, credentials, and so on. And lastly, dumping credentials from the SCM. So this is going to be using a third-party tool. I think I'll be using GitLex for this. Yeah, third-party tools, preferably GitLex. Okay, and or you can also use anything. You can use Git Guardian, you can use your own tool. You can also do it manually. Again, it depends upon what is your preference. So this is the thing that I'll be using. I'll just add this onto my slide, so I don't want these things to be missed. In case I'll be sharing the slides as well. Okay, so just a sec. So these are a couple of things that I'll be doing. Demo. Okay, so let us try one. Okay, so yeah, first let me go to the pipeline poisoning. So what we are going to do here? So we are going to so first thing is we are trying to do or manipulate or run codes directly on our CI/CD tool, right? So first, let us do that. Let's say I'll be using this white rabbit. So I have multiple branches here. I have already done a couple of POCs on it. So what I'm doing here is, so the first project, what is happening here is we have a code repository. So and we have a Jenkins file here. So the this code is configured in such a way that whatever or yeah, this is configured in such a way that whenever a developer pushes a code or as a pull request, whatever instruction that is present here will start being shown to the user, or literally just by as even though I'm not a master developer, I would be able to manipulate this overall Jenkins file. I can read the credentials that is stored on the Jenkins. I can, like, the same one that I was trying to explain. I can directly dump the credentials, private IPs, and keys from the CI tools. I can also hijack the pipelines. I can make whatever to be executed here, and lot more things. Okay, so let us without wasting much time, let us start working on it. So first, let me clone this repo. So I'll be doing two attacks in a single slot here. I'll be dumping the credentials from CI tool. Okay, and secondly, I'll be hijacking the pipelines. I will be writing some code. I'll be writing some commands to hijack the CI/CD tool. Okay, so first let me clone this repo. For cloning, let me take my repository. Let me go to this desktop. So create a simple thing. Mistake on, and let me clone this repo. Right, rabbit. Yep, I have got cloned. Let me log into it. So this is the like question. Let me just edit this Jenkins file. So what I'm trying to do here is I'm just manipulating the Jenkins file. So if you observe, I'm not doing it on a master branch. I'm not a master branch user here. Let me remove all the unnecessary code here. I don't need all these unnecessary code. Okay. This closing. Oh, I think I made a mistake. No. That's 1, 2, 3. Yeah, that should be fine. Yeah, this will be fine. Okay, so I'm just editing the files. Let me put my commands here. Let us say there's one environmental variable. Let me add it. So there's one environmental variable here. This is the first challenge actually for CI/CD. Goat. So where we have a flag one, which is hard coded onto the CI/CD. It's again a secret that is present in a what is it called in your Jenkins. So let me just flag out that. Now, the main problem that we have in Jenkins, or in almost all the CI tools, is that you cannot echo the secrets just like that. Okay, so if you just echo, let me also show that once. Let me just directly echo this, and let's see. And also at the same time, let me also run some other commands. Let's say let me run commands like ifconfig ampersand umi ampersand and uname affiliate. So if you observe, I'm just running these commands on the CI. So when this command runs, I would be getting information about what platform this CI tool is running. So I'm doing two things here. If you observe, firstly, there is a file that is stored in, there's a credential or the yeah, there's a credential or secrets that is being physically stored on the CI machine. So I'm trying to get that value just by manipulating this Jenkins file that is present on the Git. And secondly, I am running certain commands on the victim computer, or this basically this CI tool. So here I can run any command. So this is a very common command. Like, I'm just trying to get the IP address, just trying what as which machine the as which user this machine is running, and what is the operating system and version. As of now, it's very simple, but you can make it more deadlier. So you can also have a reverse shell if you want. You can literally, you can crash the entire mission, right? So you can make the mission inaccessible if you have a pseudo permissions. There are a lot more things that we can do. Let me just save it. So now, if you're wondering how did I get this, how did I come to know that this is a secret here? It's a part of a challenge actually. If you go back to, is it called, yeah, this challenges, I think it should be, this IP should be, yeah, this. Okay, it's a part of a one challenge, so that is where you come to know that this is the secret value. It's an easy one. So if you observe, yeah, there you get. Again, it's a low hanging fruit, so you can give a try as well. So this is where I came to know that there's a secret here. Again, you can give a guess, because usually, like, instead of giving flag here, you can try to give something like a username, because most commonly we would start giving username or private key. That's the word that we use. Here we are just taking example of flag one because that's how the credential is stored. And real world, you can use something like a username, password, or creds, or USER, or PWD. That's a flag we can usually give. So yeah, not much time. Let us save this file. Let us get into action. So I have saved my file. Let me store it into a different branch. Let me check out this as Mysticon. I hope I'm using the right word, or else Melvin will hit me out. Okay, so let me check if the spelling is correct. Okay, I'm not sure. Okay, yeah, it's the mistake of words, misplacement of words. Sorry. Great, great. So I'm just putting it in a different branch. Okay, I mean, at least at this initial, and then let me add the files, add the comment. This is, let me put it this way, mysticon demo. Let me check if everything is made changes. So yep, it has that made changes. There are a couple of deletions, there are a couple of additions. Yep, let me push it origin. So I have already logged in as Alice, so no need to worry. So let me push. Yep. So my code has been pushed for Mysticon. Is a new branch called Mysticon. So if you observe, if I go to my repo here, so currently this repo has three branches because of my previous things. Now it became four branches. If you just observe, it has become four branches. And the dashboard. So I'm currently running this onto a project called White Rabbit. So the moment I initiate or run this particular CSE, it should start trigger here. As of now, we already have 6 pull requests. The previous ones, a couple of hours earlier. So let me start a pull request. So before pulling to pull request, let me check what are these branches. The branch that I created right now is Mysticon. And if you observe, entire thing is same, just the Jenkins file has been changed. And let me show the Jenkins files. The full-fledged file has been shorted into a small file. All it has is echoes a flag. So if you observe, I'm just rawly echoing the file, nothing here, but I'm also running the commands here. Okay, so let me create a pull request. Okay, so I click on pull request, and I'm pulling from mysticon to main. And if you observe, there are a couple of changes. I'm adding the environmental variable, and I'm editing this, deleting these certain files, and I've replaced certain things. Click on new pull request. I'll leave the command as it is. Click on create pull request. So my pull request is created. In a couple of minutes, it should automatically trigger the build. So now this part, it depends on various things. Usually, what happens is when developers raise a pull request, just to check if their code is really working well or not, the DevOps would automatically create another automate step so that their pull request would automatically run. So that is what we are trying to exploit here. So it will take a couple of seconds. Yep, let's start it here. Start in the queue. So it will take, yeah, you can see it got failed for some reason. Let us check what happened. Yeah, because of the value flag one. Okay, I think it was same. Let me quickly check. I have made any change. It is flag one. Just give me a sec. Let me check my backup files. It should be the same way, but let me quickly check it out. Dollar flag one. That's how it is. Oh, my mistake. Okay, sorry. This should be enclosed with creds. My mistake. My mistake. My mistake. So let me credentials. I forgot the syntax. So let me quickly think it should be enclosed within double quotes. There are a lot of commands that you work on, so sometimes you forget it. Let me quickly open my new tab. Have just sharing it. Playground. Just working around with this. Let me quickly check. Yeah, I'm correct. So since I have updated it, so I have to run it once again. Okay, so let me again push commit demo one, and then that I can push origin. I have pushed. Now let me raise another pull request. Sorry for the typo, guys. Go back to where it, back to my branch. Okay, sniffers of organicals to go. Mysticon to Wonderland, main. Yeah, there it is. Pull request. So this should trigger the build. I'm just trying to like, obviously yes. Now the secrets will not be populated to you directly because we have not encoded it. We are just directly trying to access it. Again, it's got failed. What happened? Sorry for the typos. I think I again made it some typo. Just give me a sec. Let me just copy paste the file. So sometimes we make no mistake. Let me just copy the code as it is instead of typing it. Yeah, so what I made. I missed the. I've added the what's it called? Uh, dollar symbol there. My mistake. supposed to be what is it called, substituted here. Add some overconfidence. Sorry for that. Okay, this should do the job now. Okay, so great. So yep, build get commit to and get push to mistake on. I hope the changes has taken effect. Let me quickly check the branches. Mistake on. Just cross verify once. Okay, and then let me go back here. Pull request, pull from Sticon to main. Sorry for the late guys. Um, it'll take some times. Let's wait for a while. Should be triggered. It triggered. Hope it's working fine now. It's waiting. And yep, obviously it's failed. But if you see, here it is. So it has failed for the ifconfig and a couple of other commands. It obviously is. It has tried to execute, but it has got failed. Probably ifconfig was not installed there. It's basically a Docker image, and it does not have ifconfig there. That's the reason it has failed. But yeah, at the same time, if you see, the echo is giving you only the stars. Okay, again, ultimately that's what I wanted to show you. I wanted to show you these two errors because since the current Jenkins, it is not running on a full-fledged Linux environment. It is running on a Docker. So obviously it is not running, it's not going to be showing you the commands. So you should be well exploiting it. You should be very cautious about what the commands you have. So make sure you give the default commands. So obviously I'll be going to remove ifconfig and I'll be adding up OMI and uname. And second thing, when you just try to echo the credentials on any CI tools, it would not show you the credentials. You have to change it a bit. So let me edit it this time. Okay. So what you have to change, I'll just show you. A mistake. So first of all, you need to forward that to something else. So in Jenkins, you can use a simple way, that is you can just change it into base64 and you can send it. So you will be getting the base64 encoded version of the flag. But in terms of GitHub Actions or GitLab, even if you use base64, it will not show up. You can use 2 layers of base64, or you can just try to uh, validate, or basically the representation of text. You can just add uh, space or dots in between, or you can use SCD or TF or any text interpreter to misorganized or reorganize the text and get it done. So what I'm doing here is I'm just for Jenkins, just by using base64, it would populate your credentials. It could, so here it is just a flag, but in real world you can put your username, IP address, and everything. And secondly, I'm just asking you as which user I'm logged in and what are my details. Let me break it into elements. Okay. And okay, let me put it this only. So I don't want to overcomplicate. So I'm just basically encoding the flag into base64, and secondly, I'm just taking up certain information about the server. Okay. So now let me add it. Add commit demo3 and push it. Pushed. Let me go to my uh, what's it called? My folder. Let me check the commits, and we have 15 seconds ago. Let me check the updated part. Yes, we have changed the base64 version and have checking the versions details here. So let me go back. Let me create pull request. I want to pull it from Mysticon to main, and I'll click on view pull request. So wait for a second. Should it populated now? In a moment. Yeah, it started. Now let's go back to the Jenkins. Go back to this PS6. So PS7 is still happening. Yeah, it got successfully run. Now we observe it is got successfully run. If you scroll down, you can easily see a base64 coded here. Okay, and secondly, if you observe, we are running as a Jenkins user. It is not a root anymore. It is a Jenkins user. And secondly, these are the information about the system. So it is running a Kali based Docker there, and this is the current version. So let us also cross verify, or let us also decrypt this code just to verify. And let me decode it. Echo code. So this is the value of the flag. This is actually the value of the flag, but in real world you could also um, get the credentials. Now for the credential part, let me show you another example, which I've done it on my GitHub Actions actually. So the same thing will also work on any repository, so you can also get it done on GitHub Actions. So I'll not just show you, I'll show you an example of it. So if you observe, this is the code that I've written, very similar to what we have done with Jenkins. So if you observe, we had three secrets in GitHub Actions. So we have I have private key, I have a host, and I mean, there's nothing but IP address, and this is my username. Now, obviously, this is a very critical element because here I'm deploying my server here. So I have obviously yes, I'm not done anything on the private key, but if you observe, I've done the same thing for hostname. So I'm trying to use the same mechanism that we use for Jenkins here. But for hostname, it does work. But if you're trying to echo the passwords or username, that will not work with GitHub Actions. So I'll just show you how does it look when you run this PR code. The same mechanism I've tried here. So if you observe, I have not triggered it from my user. I have triggered it from a different user. So ultimately, let me show you the output for you. If you observe, see, this was not run. This was run by Hack with BKB, but manually run by Hack with BKB. But if you see, these are all run from a different user. See, this was actually run by a different user. So let me show you that. So it was also executed from a pull request. And if you see, uh, if you observe, it has echoed your host name, but it has not echoed the username. Okay, why? Because here, if you see, I'm just trying to echo it as base64. That's the reason for username. It is not echoed. It is only echoed as from a host name. But let me show you how does the host name looks like. So echo. See, it is a private IP. So no worries. This machine is not up now. I've already registered it. It is only the value. So this is what happens when you just store it. Let me show you. But how do you get this value for GitHub Actions? You do have a step. No worry. If you want to download secrets for GitHub, then instead of using base64, you can use the SED, where you are just adding a space between each character. So the current username, the host name here or the IP address was base64, but that I've added as base64, and the username here is Ubuntu. Okay, so these are the ways how you can exfiltrate or dump the credentials from a CI tool. Again, it is just a tip of an iceberg. You can do a lot more things. There are multiple ways of doing it. There are multiple ways of performing various things here, just with the mechanism that I showed you. But these are the a few ways how we can perform. And there's one more thing which I wanted to show you as well. So I hope this part is clear. And after this, we will have a short QA, so you can ask your queries as well. But before that, before winding up, I'll just show you another tool, which is pretty cool, majorly for GitHubs, but you can also use for any Git, something called Git leaks. Now, this is pretty helpful when you have any hard coded credentials. Now, Let's say if you take example of any secret scanning tool like SemGrep or any tools, they would only scan for secrets that is there in the current repo or the current build. Now, the good part of GitLex, it will go through your multiple commit. So even though if you don't have credentials in your current commit, if you have the credential hardcore credential in a previous commit, so GitLex can literally go through those commits. An example of that, let me show you. So we have another deliberated repository here. Let me show you that, adding that as an example. It should be something like dash, if I'm not wrong. Let me show you there. Dash, dash, dash. Everybody is awake for so that you can have food. Okay, so this is a repo that we are gonna use. So we dump. Let me clone it. Okay. If you observe, this machine does not have any major credentials. Okay. So if you see, let us run GitLex on it. So I think I need to download and install GitLex. Oh, GitLex is already there. Great. So just give a sec. Yeah. So git leaks. Oh, I forgot the commands. Let me go back to the repo. Yeah, mistake detect source. I'm a bit lazy about writing the commands. So let me. So if you observe, we didn't have much critical files here. So if you see here, there's no private key at all. But if you go down, you can see a lot of private keys here, which was in the previous commit. You can see here. There was also password, PyPy password, which was there in a previous commit. Again, another private key in the previous commit. There was a JWK key in previous commit, and again a couple of private keys, RSA keys, and so on. Okay. So like this, we could use some third-party tools to go forward and get your values. So again, this again, as I said, these are a couple of just a tip of an iceberg, frankly speaking. So, but you can do a lot more things. Again, these are a couple of attack vectors that you can try. You can like look for like hijack pipelines. You can execute whatever commands that you want. In our case, it was a container, so that's the reason why it was a pretty limited in the nature. But in the real world, you can explore it in a wide variety of ways. And next, obviously, yes, if you're showing the credentials, majority in CI we do show the credentials. So if you somehow happen to hijack it, obviously you can download all the credentials. And lastly, sometimes if you have updated your hardcore credentials, but it's required to remove the commit itself from its structure. So that's what these demos say. So that's about myself. I think we will have the remaining time. I think we have another 13 minutes left over, so we can have that for our Q&A. Michael, and sorry, my mistake, Melvin. These are my online handles. So you can reach out to me on my email, or so the code that I showed you, the GitHub action one that is present in my GitHub. So you can refer that, or if you want to reach out to me on LinkedIn, you can reach out to me on LinkedIn as well. So this is time for me. So then, if you have any queries, questions, please raise your queries